In this tutorial, we will learn how to create a loading screen for your LÖVE2D game. We will cover setting up the main code and managing transitions between different game states. We start by creating the main Lua file, which is the core file of any LÖVE2D project. It will handle the game logic, initialization, and screen transitions. Let us begin by setting up the main structure. The loading progress variable tracks the current progress of the loading screen, starting at 0. Loading time sets the total duration for the loading screen in seconds before it is considered complete. Elapsed time will track how much time has passed since the loading began. Loading complete is a Boolean variable indicates whether the loading process is complete, starting as false. The variable background image will hold the background image for the loading screen. The image will be loaded later in the code. Neon blue table defines a neon blue color using RGB values, where red is 0.2, green is 0.8, and blue is 1. Black table defines the color black with RGB values all set to 0. White table defines the color white with RGB values all set to 1. Loading sound, hold the sound file for the loading screen. The sound will be loaded later in the code. Require menu, imports, the menu Lua module, which contains the code for the menu screen. The menu variable will be used to call its functions. Game state variable keeps track of the current state of the game. Initially, it is set to loading, indicating that the loading screen is active. LÖVE_load function is called once at the start of the program. It is used to initialize variables, load assets, and set up the game environment. LÖVE graphics get dimensions, retrieves the width and height of the game window and stores them in window width and window height, respectively. These values will be used for positioning and scaling elements. LÖVE graphics new image loads the image file named background.png, specifying that its format is PNG into the background image variable, so it can be displayed on the loading screen. LÖVE audio set volume sets the global audio volume to 1, which is the maximum volume. The pcall function is used to safely execute the code inside the anonymous function. If an error occurs while running the code, pcall prevents the program from crashing. Instead, it returns false and the error message. LÖVE audio new source loads the sound file named loading_sound.ogg into the loading sound variable. The static argument indicates that the sound will be fully loaded into memory, which is ideal for short sounds. If the sound file is loaded successfully, success will be true. If there is an error, the error message will be stored in error. The if statement checks if the pcall function from the previous block failed. If an error occurred, it prints an error message to the console, combining the text error loading sound with the actual error message stored in error. The else block only executes if the success variable is true. This means the code inside the else block will run if the sound file was successfully loaded without any errors. We use the loading sound object and call its method setVolume to adjust the volume of the sound. By passing 1 as the argument, we set the sound to its maximum volume. Then, we use the setLooping method to ensure that the sound plays continuously in a loop. This way, the sound keeps playing until we stop it. Finally, we call the play method to start the sound immediately. All three methods are part of the loading sound object, and they let us control how the sound behaves during the loading screen. LÖVE2D function is called continuously during the game. The DT parameter represents the time passed since the last frame, which helps to keep the game running at a consistent speed regardless of the frame rate. If the current game state is loading, ensuring that the code inside the block only runs while the game is in the loading state. Elapsed time tracks how long the loading screen has been active. By adding DT to elapsed time on each frame, the elapsed time increases over time, effectively counting the total amount of time that has passed during the loading screen. This ensures that the loading progress is updated smoothly and consistently. The variable loading progress is assigned the value of the mathmin function. This function takes two arguments. Elapsed time divided by loading time calculates the percentage of time that has passed relative to the total loading time. The result will be a value between 0 and 1. The second argument, 1, is the maximum value we allow for the progress. This ensures that the progress never exceeds 100%, even if the loading time takes longer than expected. If loading progress equals 1, meaning loading is complete, and loading complete is still false, we set loading complete to true. This indicates that the loading is finished. Next, if loading sound exists, meaning the sound has been loaded, we stop the sound using the stop method. Then, we change the game state to menu, which triggers the transition from the loading screen to the menu screen. Finally, we call the load function of the menu to initialize the menu screen. The LÖVE2D function is called every frame to draw elements on the screen. If the game state is loading, it means we are still in the loading screen. We set the drawing color to white using LÖVE Set Color, which is necessary before drawing any graphical elements. Then, we draw the background image on the screen at position 000 using LÖVE The image is scaled to fit the window dimensions. The width and height of the image are adjusted based on the window size, so it covers the screen. We define the dimensions of the loading progress bar. Bar width is set to 80% of the window width. Bar height is set to 20 pixels. Bar X is the X position of the bar, which is centered on the screen. Bar Y is the Y position of the bar, placed near the bottom of the window. Finally, we define radius as 10, which could be used for rounded corners of the progress bar. LÖVE new font creates a new font object with a font size of 10 pixels. This function returns a font object that we can use to render text. LÖVE set font is used to set the font as the active font in LÖVE2D. After this line, any text drawn on the screen will use this 10 pixel font size. This line defines a local variable named text and assigns it the string loading. This is the text that will be displayed and measured. LÖVE get font retrieves the current active font object that was set earlier using LÖVE set font. This ensures that any text drawn afterward will use the font that was previously defined. getWidth is a method called on the retrieved font object. It calculates the width of the given text string when rendered with the current font. The method returns the width in pixels, which is then stored in the variable text width. This allows us to know how much horizontal space the text will occupy when displayed on the screen. Once again, we use LÖVE get font to retrieve the current active font object that was set previously. Then, the getHeight method is called on the font object retrieved by LÖVE get font. This method calculates and returns the height of the given text string when rendered with the current font. The result, which is the height in pixels, is stored in the variable text height. This value represents the vertical space the text will take up when drawn on the screen. Love Graphics Set Color sets the drawing color to black, which will be used for the text shadow. Next, we use two nested loops, one for DX, horizontal offset, and one for DY, vertical offset. These loops range from -1 to 1, allowing us to create a shadow effect by printing the text at several positions around its original location. Within the loops, we use an if statement to check if DX and DY are both 0. If they are, we skip drawing the text at that position because we do not want the original text to overlap with its shadow. This is why both DX and DY need to be non-zero in order to create the shadow effect without overlapping the text. Using Love Graphics Print, we print the text multiple times with slight offsets. The horizontal position is adjusted by DX. The vertical position is adjusted by DY. The text is placed slightly above the progress bar by adjusting the vertical position. We subtract the height of the text and a small value of 10 pixels from the bar's vertical position to ensure the text doesn't overlap with the bar. The result is a shadow effect where the text appears multiple times around its original position, creating a glowing or shadowed look. We set the drawing color to white using Love Graphics Set Color, which will be used for the main text. Next, we use Love Graphics Print to draw the text at the center of the screen. The horizontal position is calculated by subtracting the width of the text from the window width and dividing the result by 2 to center it. The vertical position is set slightly above the progress bar by subtracting the height of the text and an additional 10 pixels from the bar's vertical position. Finally, we reset the drawing color back to black with Love Graphics Set Color to 0, 0, 0. This ensures that any subsequent drawings use the default color. We use Love Graphics Rectangle with the Fill mode to draw a filled rectangle. The rectangle is positioned at bar X and bar Y. The bar width determines the width of the rectangle and bar height determines its height. The radius adds rounded corners to the rectangle, making it look smoother. After drawing the rectangle, we set the color to neon blue using Love Graphics Set Color. This color will be used for any subsequent drawing operations, including the progress bar. Next, we draw another rectangle using LÖVE2D rectangle with the fill mode. This rectangle represents the progress bar itself. The width of the rectangle is set to bar width multiplied by loading progress, which means the width of the bar increases as the loading progresses. The height of the rectangle remains the same at bar height, and the radius ensures the rectangle has rounded corners. After drawing the progress bar, we set the color back to black using LÖVE2D set color. This prepares the color for any future drawing operations, like the border of the progress bar. We set the line width as 2 using LÖVE2D set line width. This ensures that any subsequent shapes drawn with lines will have a thickness of 2 pixels. Then, we draw a border around the progress bar using LÖVE2D rectangle with the line mode. This mode draws an outline or border instead of a filled shape. The position of the border is adjusted by subtracting 2 pixels from both the bar x and bar y coordinates and adding 4 pixels to both the bar width and bar height. This ensures the border is slightly larger than the progress bar, surrounding it with a border of 2 pixels. The radius ensures the corners of the border are also rounded. We calculate the loading percentage by multiplying loading progress by 100. Then, we use the math floor function to round the result down to the nearest whole number. After that, we append the percent symbol to the number, creating a string that represents the loading percentage. Next, we calculate the width and height of this percentage string. We use the LÖVE2D get font function to retrieve the current font being used for drawing text. This function returns the font object. Once we have the font object, we call the getWidth method on it to calculate the width of the percentage string. Similarly, we call the getHeight method on the font object to determine the height of the text. LÖVE2D set color is used to set the drawing color to black for the text shadow. Then, we have 2 nested for loops. The first loop runs for dx from -1 to 1, and the second loop runs for dy from -1 to 1. These loops allow us to create multiple copies of the text with slight offsets, forming a shadow effect around the original text. Inside the loops, we have an if statement that checks if both dx and dy are equal to 0, which would place the text at the center. We do not want to draw the text at the center position for the shadow, so if dx and dy are equal to 0, the shadow will be skipped for that position. For each non-center position, LÖVE graphics print draws the text at the calculated position with the offsets dx and dy. The horizontal position is calculated by subtracting the width of the text from the window width, dividing by 2, and then adding dx for the horizontal offset. The vertical position is calculated similarly, but the offset is added by dy. This process repeats for each position determined by the loops, creating a shadow effect around the text. LÖVE graphics set color is used to set the drawing color to white, which will be used for the main text. LÖVE graphics print is used to display the percentage text. The horizontal position is calculated by subtracting the width of the text from the window width and then dividing by 2 to center it on the screen. The vertical position is set by subtracting the height of the text from the height of the progress bar and then dividing by 2 to ensure it is centered vertically within the bar. This places the percentage text at the correct location above the progress bar. The variable version text holds the version information for the game, specifically the string, version 1.0.0. LÖVE graphics getFont is used to retrieve the current font and then call getWidth on it. This method calculates the width of the version text string when rendered with the current font, and stores that value in the version width variable. We calculate the x-coordinate for the version text by starting at the bar's x position, adding the bar's width, and then subtracting the width of the version text. An additional 10 pixels are subtracted for padding, which places the version text near the right edge of the progress bar. We calculate the y-coordinate for the version text by starting at the bar's y position, subtracting the text height, and then subtracting an additional 10 pixels for padding. This places the version text just above the progress bar. Again, we set the drawing color to black using LÖVE2D set color. Then, we use two nested loops, one for the horizontal offset, dx, and one for the vertical offset, dy, both ranging from -1 to 1. Inside the loops, we use an if statement to ensure that the text is not printed at the center position, which would result in overlapping the original text. For each iteration of the loops, we print the version text with slight horizontal and vertical offsets, creating a shadow effect around the text. This ensures the text appears with a shadow, making it more readable against the background. We set the drawing color to white using LÖVE2D set color for the main text. Next, we use LÖVE2D print to draw the version text at the calculated version X and version Y coordinates. This places the version text in the desired position on the screen. Next, we check if the game state is menu. If the game state is indeed menu, we call menu draw. This calls the draw function from the menu module, which is responsible for drawing the elements of the menu on the screen. By doing this, we pass control to the menu module to display the menu when the game is in the menu state, making sure the menu is drawn properly. Finally, the end keyword closes the if condition and marks the end of the LÖVE2D function, which is responsible for rendering the visuals in the game. Now, we will create a basic menu Lua script in order to test our loading screen. We create a new table called M, which will act as a container for the menu-related functions and variables. Next, we define a function mLoad. This function is meant to handle the loading or initialization of the menu when it is called. Inside the mLoad function, we use print. This will output the text, "Welcome to the menu," to the console or terminal when the function is called. This could be useful for debugging or confirming that the menu is loaded successfully. We define a new function mUpdate. This function is intended to handle any updates related to the menu, such as checking for user input or updating animations, whenever the game state is in the menu. Currently, the mUpdate function is empty, meaning that no actions or logic are being performed inside it. It serves as a placeholder for future updates related to the menu. The function mDraw will handle the drawing of the menu on the screen. First, we clear the screen and set the background color to a dark gray using LÖVE2D Clear. The parameters 0.1, 0.1, 0.1 represent the RGB values for the dark gray color. Then, we set the drawing color to white using LÖVE2D set color so that the menu text will appear in white. After that, we draw the main menu text using LÖVE2D printf. The text is placed in the horizontal center of the screen, and the vertical position is set slightly above the middle of the screen by subtracting 50 pixels from the middle height. Next, we draw the press back button to quit text. This is also centered horizontally, but its vertical position is just below the main menu text. We define the function LÖVE2D to handle touch events when the screen is touched or tapped. The ID parameter represents the touch ID, which uniquely identifies the touch event. The X and Y parameters represent the coordinates where the touch occurred on the screen. The pressure parameter indicates how hard the touch is, though it is not used in this case. Inside the function, we call LÖVE2D, which triggers the game to close or quit when the screen is touched. This is commonly used to handle events like quitting the game when the user taps the screen. The function LÖVE_GamePad_pressed is used to handle gamepad input when a button is pressed. The joystick parameter represents the connected gamepad or joystick. The button parameter represents the specific button on the gamepad that was pressed. Inside the function, we check if the button pressed is back. If it is, we call LÖVE_EVENT_QUIT to quit the game. This ensures that pressing the back button on the gamepad will close the game, just like pressing the back button on a mobile device or the escape key on a keyboard. Finally, the line return M returns the M table, making it available to other parts of the program. This allows other parts of the code to access the functions and variables defined within the M table and ensures the menu module is properly integrated into the game. Make sure all the necessary files are in your working folder before testing. This concludes our loading screen tutorial.